I'm Adam Baker. I'm a PhD candidate in the bioengineering program. I just recently completed my certificate in engineering and science education. And so I'll be going over my project on confidence and creativity in bioinstrumentation design. So rather than looking at all this, let's break it into our little parts here. So I first started with this common observation of biomedical engineering students feel like they are a mile wide but an inch deep. They feel like they're jacks of all trades. They take this wide course load, but they don't feel like they've super specialized. So when they get to my class, at the end of my class, they need to design a project for a biomedical purpose that involves some coding and circuitry at the end. And a common question is, what can I even do? And so my hypothesis was that there's an actual interruption of the development of engineering identity, and that is linked to the actual creativity and design process at the ideation stage. So there are several other observations that we made at the beginning based on students. Like I said, students, this is their first design experience. We have something called, I'm terming electrical anxiety. They're stressed out from physics too. They come to my class, they say they hate circuits and everything. They feel like they're jacks of all trades. There's a lot of feelings and emotions going on. And from the instructor's perspective, when it gets in the design stage, they're feeling like, oh, these projects aren't really challenging them. They aren't very creative. This generation is soft. They don't know how to take feedback. And so I was hearing all these different, making all these different observations. My purpose when I did this project was I want to, one, improve confidence in the early design process, and two, improve performance by clarifying maybe some of the expectations that the teaching assistants were feeling to help improve the outcomes on the student end. So generally what we did is something very similar to Shark Tank. We did actually 2 rounds of Shark Tank. They do a brief presentation that covers basically the need, their design, and then we give them some critical feedback afterwards. Before the presentations, they were surveyed on their confidence of the lab, the lecture that's paired with the lab, as well as the final project. Then after the presentations, we gave them this quantified but subjective score from each of the instructors on a scale from 0 to 10. We called these creativity, clarity, and overall. Creativity, rather self-explanatory. Clarity was mostly, does your design does your design clearly fit the problem that you've encapsulated in this project? And then overall was basically a percentage grade of how likely we thought the project would actually work. And then after the presentations, they got that critical feedback that was very, very specific. And so our idea was, can we measure confidence and creativity and all these other metrics and understand the student identity formation? So we took there's a lot of data involved with this, and I want to just hit on a couple of them. Is that generally everyone improved before and after getting feedback from Shark Tank 1 to Shark Tank 2 on a median score improvement of about 1. But if you look at this specific group that I highlighted in red, this outlier group, they're groups that completely changed their project. They did Shark Tank 1, they hated it, or they hated the feedback that they got, and they went completely different. And they ended up going way over the expectations of the instructors and had some of the best creative projects of the semester. So some students really, really responded to having that clear feedback, and after seeing their peers' projects, they decided to challenge themselves and really go above and beyond. Confidence in general was rather complex and measured in a lot of different ways. But in general, before and after the first pitch, when they get that critical feedback, there didn't seem to be that serious of a change, which kind of goes against this idea that like this generation is soft. They took very critical feedback and they seemed generally unbothered in their ability to think of themselves as being able to complete the project. But if you took the span of the entire course after all of the pitches, it seemed to actually generally increase. So this confidence creep seems to either be a part of their own self-reflection, or as they began to actually build the device and actually conceptualize more parts of it, that they actually improved. So generally, what did we learn? The reflections from the instructors and the teaching assistants agreed that students improved. However, to really understand this, I think we need to do some more mixed methods, some qualitative coding of the reflections from instructors and students. The actual metrics, overall clarity were kind of mixed. We actually keep doing this grading from the instructors because we liked this so much. We thought it was so helpful for that one semester that it's now standard for this class. We include something called rigor now, which now actually kind of grades like how hard the project is. But we're probably going to add clarity back this semester. Um, Skills are necessary for confidence. While we didn't see a huge improvement, it means that probably any confidence that's gained actually comes from doing hard work and actually proving the skills in a physical manner to themselves. So confidence is not so easily swayed by just critical feedback either. We saw it pretty stagnant across a single reflection. And then lastly, creativity improved once they saw their peers work. Biomedical engineers are not just jacks of all trades. They're in fact experts on needs-based design, and they're looking for evidence that they can create great things. Once they know it is possible, they're ready for the challenge. So thank you very much.